Hello, welcome. Today we're going to talk about the 24 game, which is a really interesting puzzle that involves four numbers. So here's the rules. Hello, Jie. We're just getting started. You're just on time. So what is the 24 game? Basically, every puzzle has a unique set of numbers, right? You have four numbers to be exact. Now, in the standard version, each set has four numbers, and what you have to do is that you have to combine these four numbers somehow to form the value 24. Now, in the standard version, you can use whatever combination of addition, subtraction, multiplication, or division between the numbers. But in harder problems, in which we'll get to later, we're going to restrict the types of operations you can use and even introduce some new and unique ones. So now let's look at an example just to be sure. So basically you have four numbers, right? 5, 5, 4, and 3. And what you want to do is that you want to put four operations between them such that you can get the number 24. Right? So see if you can solve this. I'm going to give you guys a minute, see if you guys can figure out what operations you have to put in the blanks to get the number 24. Lloyd, Jasper, do you guys have any ideas? Jasper, would you like to give it a try at this? Also, you guys can feel free to, like just draw on the screen, like experiment. If you can like draw, feel free to just annotate on the screen, right? Try experiment. Can you guys annotate? It's okay, Jasper. Basically we're playing this game, right? For anyone who just joined, we got this 24 game here, right? So you have four numbers and you want to somehow combine these numbers to form the value 24. And you can use whatever combination, right? So just to give an example, see, you see here in this puzzle, we have five numbers, right? And what you want to do is that you want to add or subtract or multiply or divide these numbers together to get the value 24. So in this example, what you might do is that you might add 3. Oh, does someone have an idea? Wait. I see your hand raised. Do you have something to say?
I mean, like, can I say the answer to the question?
Yeah, sure. Go ahead.
Like, like 5, the between the two fives. I think I should. You should do times, and
Like
then
this.
-4 plus
Okay.
3 equals 24.
Exactly. There we go. Yep, Jasper, apparently you also had it. It's okay. We have a lot more puzzles for you guys to try. But yeah, basically this is the gist of it, right? So good job, you. Basically you have four numbers and you want to use operations to combine them. That's it. Okay, so now let's look at a harder problem, right? So now you've got this slightly more complicated one. So I'm gonna give you guys like 2 or 3 minutes and see if you guys can try it. And also, can you guys annotate on the screen? Because y'all can feel free to just like, draw on it and experiment to like test. You can't. Okay. Let me see if there's a way I can. How do I allow you guys to annotate? Okay. Um. Oh, was that someone that annotated? Oh, it works. Okay. Can someone write like a hi or something just so I know it works? Okay. All right. Well, I'll give you guys like 2 minutes, see if you can figure it out. You can draw on the board if you want to. Oh, you guys see your hand raised.
I don't understand what you mean.
Like you can, if you press on the pencil button, you can draw on the board. So
No,
you
I
can,
mean the puzzle.
oh, so you want to combine these four numbers to get 24. The goal is always 24. That's why it's called the 24 game.
Okay.
Yep, you always want to get 24. So maybe you'll do something like 8 times 8 plus 4, but I don't think that works. So see what you get. How would you combine these four numbers to get 24? Hey, Loy and Jasper, you guys can feel free to write on the board too, just to find the solution. Did anyone find the answer? No? Okay. Well, let me give you guys a hint, okay? In this particular puzzle, we only use addition. Add them together. Yes, you can use parentheses. So you can do something like 4 plus 8 times 4 plus 8. So you can use parentheses. But in this particular one, I don't think you need to. Yeah, this is a pretty simple one. Oh, we have a little traffic jam, huh? Okay, well, it looks like two of us already got the answer. So yeah, it is just 4 plus 8 plus 8 plus 4. Good job, Lloyd. Good job, Yue. Exactly. This is a really simple puzzle. All you have to do is simply add them together, right? 4 plus 4 plus 8 equals 24. Nice. Good job, guys. So now let's try a slightly harder one, shall we? Okay. 1, 9, 5, and 5. How would you combine these numbers to get 24? How do you get rid of the tool? I think if you just click the pencil icon again. Oh, wait, actually, when you click the pencil icon, you should have like a little bar. So if you click the X, you should be able to get rid of it. I mean, I would encourage you to write something on the board to, try out the problem. Is anyone making any progress? Lloyd, Jasper, are you guys stuck or are you just thinking? Ooh, looks like we have an answer. All right, guys. So Loy got the answer. So yes, Loy, you are indeed correct. So this one is slightly trickier because you actually have to use parentheses. So the right answer would be 5 plus 1 times 9 plus 5. Oops, 9 plus 5. So that would be equal to 6 times 4, which is 24. Just to make sure, does everyone here understand how parentheses works? Yes, okay. Right, so basically in this puzzle, you had to use parentheses because if you don't first add 5 and 1 together and then multiply by 9 minus 5, there's no other way you can get 24. So yes, good job, Loy. You found the right answer. The answer is indeed just this. Yes, Yuan, do you have a question?
Is a parenthesis mean like the thing inside has to add first?
Exactly. Yes, you know your PIMDAS. Yes, Jasper, always equal 24. So basically, you have, as an example, usually if you have like 5 plus 2 times 4, you would have 5 plus 8, right?
Yeah.
But if you have a parentheses, then what you do instead is you do the parentheses first, right? PIMDAS, you always do the parentheses first. So then if you write 5 plus 2, but you have a parentheses around it, and then times 4, you would actually have 7, right? Times 4 equals 28. So look at these two examples. Notice how even though the numbers and operations are the same, if you have a parentheses, you'll get a different order of operations and thus a different answer. Does that make sense?
Yes, but I still have a question. How does it make a difference? Like 5 plus 2 times 4, how does it make a difference with the parenthesis and without the parenthesis?
Well, that's a great question because if you look at this one first, right? If you look at this one, you see that when you don't have a parentheses, multiplication always comes before addition, right? So you have to evaluate this before you can evaluate this, right? So this is number 1, this is number 2. But then if you look at the other side, when you have a parentheses, you evaluate the parentheses first, right? So you have this first and this second. So on the left side here, you first have 2 times 4 equals 8, number 1 step, and then you add that to 5, which is number 2 step. So that gives you a 13. But on the other hand, you first do 5 plus 2 equals 7. So this is your number 1 step. And then you multiply by 4, your number 2 step. And that gives you a different answer. Does that make sense? Yeah, okay. All right, good job, Lloyd. Let's now go on to another puzzle. Just as a quick hint, this one will also require parentheses. This one will require parentheses. And also, if you find the answer, maybe don't type it out into the chat. Instead, maybe just, like keep it to yourself. And if you're done, just type "I'm done" or shout out "I'm done" or something. And then when we feel like everyone's kind of already tried it, then we'll reveal the answer. Okay. Dang, Loy, you're fast. Okay, let's give. Oh, you also got it? All right. Okay. Well, why don't you two type the answer at the same time? type the answer into the chat. Or if you would like to just write it on the board, you can do that too. Huh. Okay. Guys, remember that we're always aiming for 24, right? So 4 plus 8 times 1 plus 1 wouldn't really give you 24, right? Because if you evaluate it with the order of operations, you would get 4 plus 8. Oh, you're doing, okay, you're putting it in parentheses. Ah, okay, okay. There we go. There we go. All right, good job, guys. Yeah, that's why the parentheses is particularly important, right? Because if you don't have it, it changes the order. But yeah, this is the correct answer. The correct answer is 4 plus 8 times 1 plus 1, which is equal to 12 times 2, which is 24. Good job, guys. All right, just to solidify things a bit, you're gonna use like 2 minutes to go over PIMDAS. All right, yeah, Jasper, it's a fun game. PIMDAS. Hopefully all of you already learned this, but I'm gonna spend like 1 minute to review this just to make sure, right? Okay, so PIMDAS is the rule for the order of operations, right? So this is first, this is second, third, fourth, fifth, sixth. Right? So what the P stands for is parentheses, right? Parentheses always go first. These are the things like this or like this. These always go first. The E stands for exponents, right? We're actually going to talk about exponents very soon, but exponents always go second, right? So you got exponents. And then third, you got multiplication, right? Multiply. Right, that's right, Loy. Multiply. And then you got, actually, I'm just gonna write the symbols. You got division, you got addition, and finally subtraction, right? So this is always the order that you're going on, right? Does anyone have any questions about this? Yeah, go ahead, Yue.
What's extermination?
The E?
Yeah.
Okay, this is a surprise, but we're gonna go over this really soon, okay? It's in like after 3 more puzzles, I believe. But you know what? Here, it's just something that looks like this, like 2 to the second power. It's basically equal to 2 times 2, but we're gonna talk about this in like 20 minutes, okay? So hang on. All right, now let's go to the next puzzle. This is level 2 cards, so they're kind of hard, actually. But go ahead, give it a try. Jasper asks, isn't it like 3 and 4? Which one comes first? You do first. Oh yeah, yes. For PIMDAS, addition and subtraction, yes. The order doesn't really matter, but just for like the sake of teaching, they usually do this. But yes, Jasper, you're correct. Okay, Loy and Jasper are done. Let's wait 1 more minute Done. All right. Well, go ahead and share your answers. Feel free to either type it or write it. Okay. Well, Yuan and Loy, good job, guys. This is the correct answer. Um, would one of you like to explain it to us? Just go over the steps, but you guys have the correct answer though. If not, yes, we can move on. Basically, 4 minus 1 is 3 plus 21, 24. Great job. All right, next puzzle. All right, guys, wait one more minute. All right, looks like we're all done. Go ahead and tell us your answers. You're very close. All right, so okay, looks like we've all pretty much got it. The answer is 2 times 7 plus 2 plus 8. And in this case, you actually don't need a parentheses, right? Because if you do this thing here, yes, you'll get 10 plus 14. But if you just leave the parentheses out, you'll still get 2 times 7 plus 2 plus 8. And by the order of operations, this would still go first. So you'll still have 14 plus 2 plus 8, which still gets you 24. Yep. Well, good job, everyone. Now let's move on to the third puzzle. Oops. There we go. All right. I know, right? This one's kind of tricky. Wow, Loy, you're good at this. Don't give the answer yet, though. Let's wait 2 more minutes. All right. Okay. Well, go ahead and type your answers. Good job, everyone. Good job, Yue. Good job, Loy. Good job, Jasper. You guys got the right answers. You guys are kind of good at this, because like some of these took us a little while to solve. But yeah, you're right. Jasper, you're right. That's the right answer. It's 4 times 7 minus 5 minus 1. In this case, you actually don't need the parentheses either, because what you could do is 4 times 7 minus 5 and then plus 1, right? Because then you would have 28 minus 5 plus 1, which is still 24. But either way works. And good job, guys. All right. Now that we are done with these puzzles, we got level 3 puzzles. So I'm going to give a hint here. These ones are kind of hard, and this one actually involves division, right? So that's a hint for you right there. Yes, Yue? I know, this is a hard one. Okay, looks like some of us are done. Let's wait 1 more minute, okay? Thirty more seconds. All right, feel free to type your answers. Oh, Jasper, you got it just in time. Oh, wow, it actually looks like we have some different solutions here. That's interesting. Well, Jasper, yeah. So apparently this one has 2 solutions, right? And the one that we found, you do have to divide, but apparently one of them you don't. So good job on finding the other one. All right. So, yep, you guys both got the right answer. I mean, you three both got the right answer. But yeah, basically this one has 2 different answers. One of them is 5 times 8 minus 2 times 8. And that would give you 40 minus 16 equals 24. So that's one solution. I'm going to take this out of the way real quick, okay? But then you have the other solution, which is 5 divided by 5 plus 2 times 8. And if you work this out with the order of operations, you would have 1 plus 2 times 8, which is 3 times 8, which is 24. So as you can see, some of these puzzles do have 2 solutions, and sometimes you have to have multiple people to find all of them. All right, cool. Let's go on to the next one. The solution we found doesn't really require division, but maybe you'll find one that does. But the one we found doesn't. I know level 3 is hard. Hey, Lloyd. All right, let's wait like 1 more minute. Jasper, let us know when you're ready. Oh, he got it. All right, well, you two can type your answers too. Huh, okay. Okay. Well, okay, here, let me reveal the correct answer, because some of us kind of got the right answer, but like one of the signs isn't quite right. So no, Jasper, you were correct, right? Because if you did 28 plus 4 minus 8, that would be plus minus 4. So that would be 24. But if you change it to negative, then you actually have a 28 minus negative 4. So that would give you 32. So you were actually right to begin with. Oops. But the right answer is 4 times 7 minus 8 plus 4. That is the correct answer. And if you evaluate it, you see it's 28 minus 8 plus 4, which is 24. Good job. All right, let's see the final level 3 puzzle, and then we'll move on to something new. This is like the grand finale. And you know what? This time, why don't you send your answer to me privately, okay? Send it to me via private chat. Yeah, you.
I don't know how you do private chat.
Oh, it's okay. Then you can just write the answer on the board when I tell you to do so. But right now, just hold on, okay?
Okay.
All right, okay, you can go ahead and write your answer. Oops. Oh no, not the spoiler. I know, Jasper. Good job. Good job. No, it's right. It's the right answer. Hey, it's okay if you can't solve this one. It's a really hard one. So let me know if you want to see the answer. That's okay. I mean, as long as you solved it. All right, guys, I'm going to reveal the answer. So yes, Loy, yes, Jasper, you guys got it right. Good job. And it's okay if you can't solve it. This one is like really hard. Like this is really, really hard. So,
I just got the answer.
oh, you did? Did you get this? Okay, well, good job to you too. So yeah, this is the answer. And if you evaluate this, you'll see that this is step 1, step 2, step 3. And you get 9 times 8 minus 3. I mean, not minus, divide. And that's 72 divided by 3, which is 24. No, no, Jasper, that was right. I mean, you wrote it in like a different way, but here, I'll show you. What you wrote was you added 8 and you divided by a fraction, right? You divided by 3/8. But when you divide by a fraction, you're really just multiplying by this reciprocal, right? So then what you end up getting is that you're actually multiplying by 8/3. So basically, it's the same thing as 9 times 8/3. So it's the same thing. You just wrote it differently, and that's totally okay. So yeah, you got the right answer. All right. Are there any questions before we move on to the next stage? No? All right. Okay, so exponentiation, right? That's the E and PIMDAs that we were talking about. So what this is that basically how it works is that's really, really simple, right? So here's an example. 2 to the third is 2 times 2 times 2, right? It's 2 multiplied by itself for 3 times. 3 to the fifth is 3 times 3 times 3 times 3 times 3, which is 3 multiplied by itself for 5 times. So as you can see, the top number, which is like this thing here, tells you how many times to multiply the base, which is this thing here, by itself. So then you'll have 4 to the third is equal to 4 times 4 times 4, or 4 cubed. Yes, Yue?
So you mean if I do a 2 and the top number is 10, so the answer is 20?
No, actually. So if you have something like this, right? What you would actually have is 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see this is 2 multiplied by itself for 10 times, right? So that means exponents can get really big really quickly, right? Because if you look at this diagram over here, you see that one little cube represents 1 unit, right? But then if you have 4 to the cube, what you actually have is 4 times 4 times 4, which is equal to 64. So you can see, even though I only raised 4 to the third power, it actually gets really big really quick. And so what 2 to the 10 is that it's actually, let me evaluate this. Okay, so this is 2 to the 4 is 16. That's all of these. Another 16 times 4. So that's 256 times 4. Okay, so 2 to the 10 is 1024. So it's actually a really big number, right? So as you can see, exponentiation, again, the bottom is the base, top is the exponent. And what you're doing is that you're multiplying the base by itself, and the number of times you're multiplying is told to you by the top, right? So here, just as another example, if you have something like 5 to the fourth, that would be 5 times 5 times 5 times 5.
20.
Does that make sense? Alrighty, okay. Now, not only will we use exponentiation, we're actually also going to use radicals. Now, radicals is the collective term for square roots, cube roots, fourth roots, blah, blah, blah. But right now we're going to talk about square roots, right? We're only going to talk about square roots. So how square roots work is it's really just the reverse of exponentiation, right? So if you look at this diagram here, it's actually pretty intuitive, right? So you know that 2 to the second power is 4, right? That's exponentiation. So therefore the square root of 4 is 2. 3 to the second power is 9, right? Because 3 times 3 is equal to 9. So then the square root of 9 is 3. Similarly, 4 times 4 is 16, so the square root of 16 is 4. And 5 times 5 is 25, so the square root of 25 is 5. 6 times 6 is equal to 36, so the square root of 36 is 6. And so on and so forth. Does this make sense? No, it does not. Okay. All right, let me see how I should explain this. So basically, if you look at this diagram, right, let's just look at this. 2 to the second is equal to 4, right? That's saying that 2 times 2 is equal to 4. Therefore, the square root of 4 is equal to 2, right? And similarly, if you look at 3 times 3, which is 3 squared, you get 9. So the square root of 9 is equal to 3. Okay, well, okay, looks like most of us got it. So maybe just let me know if you have any questions. But basically how it works is that if I'm telling you to get the square root of like some random number, I'm really just asking you what number times itself gives me the number under the square root, right? So if I have like the square root of 49, I'm really just asking you what number multiplied by itself gives you 49. And the answer is 7, right? Because 7 times 7 is equal to 49. So the square root of 49 is equal to 7. Does that make sense? Alrighty. Okay. All right. Okay, now let's actually put this to use by trying a puzzle. So the left puzzle is not only can you use addition, subtraction, multiplication, and division, but you can also use exponentiation, such as 2 to the third. Also, note that exponentiation requires two numbers, right? So if you do something like raising 5 to the second power, that's going to cost you both 5 and 2. So just something to note. And if you take a square root, note that taking a square root also requires a 2, right? Because you know how radicals usually have these numbers outside of them? So a square root is really something that looks like this, right? It's just that square roots are so common that normally when you write it, you don't write a 2, but taking square roots will also cost you a number 2. So if you take the square root of 16, that costs you 16 and 2, okay? So give these puzzles a try. Don't blurt out the answer. Let me know when you solve it. What number are we making? Remember that it's the 24 game, so you always want 24. I would say the right one is a bit easier than the left one. I know, right? These one are hard. I mean, you know, there's a reason I put two twos here, right? Do you have to use exponents? Yes. In these two particular cases, you have to use the exponents for the exponents. You have to use the square roots for the square roots. All right, 30 more seconds and I'm gonna reveal the answer. All right, 15 more seconds. All right, I'm going to reveal the answer simply because we're kind of running out of time here. So these two were really tricky, right? You had to use the exponents. So for the exponent question, what you have to do is you have to put the 2's as bases and then put the 5 and 3 as exponents and then add them together. That would give you 32. Sorry, not add them together, I meant subtract them. Right? Subtract them, and that gives you 32 minus 8, which is 24. And for the other one, what you do is you take the square roots of 16 and multiply that by the square root of 36, which is 4 times 6 or 24. All right, well, good job. Good job. Good job to both of you. This was a really hard one. All right, okay, do you guys know about radicals? If so, I'm just gonna skip this slide. Yes, no, maybe so. You need me to explain this? Because I got like 2 more puzzles. You need me to explain this. Okay. Well, here's a crash course. Okay, here's real quick. Oh no. Okay. All right. There we go then. So here's a mixed puzzle, right? So this one requires even more radicals, not just square roots. And again, if you take like the cube root of something, it costs you a number, right? So if you take the cube root of like, I don't know, 27, that's, oh wait, actually there isn't a number 27 here. Okay, let's just say that you took the cube root of, I don't know, 8, right? So then that's gonna cost you the numbers 8 and 3 simply because you used them, okay? So see what you can do with this one. This one's like really hard. Like this is like God level hard. So don't feel bad if you can solve this one. looks like we're all a little stuck. So I'm gonna give you a second hint. Three times 9 equals 27. Yeah, not quite, not quite. It's okay. Okay, here's a final hint. You gotta take the cube root of some number or else it's not gonna work. You gotta take the cube root of some number. Remember that the cube root of 27 is 3, right? The cube root of 27 is 3. Did I reveal the answer? Do you guys want me to reveal the answer? Or do you want to keep trying? Keep trying. Okay, all right. I'll reveal the answer. So 3 times 9 equals 27, right? The cube root of 27 is 3. 3 times 8 equals 24. So if you write it in one sentence, it's like this. It's pretty hard. It's a hard one. I know. I'm telling you, this is like insanely hard. All right. I got one more puzzle here, but we are over time. So if you want to leave, that's totally fine. But if you want to try this final puzzle, feel free to do so too. You hard. Okay. All right. Well, thank you for trying, Jasper. Have a great rest of your weekend, or I suppose great rest of your Friday. Have a great weekend, Jasper. Thank you for coming. Bye.